Hi there, welcome back. Today I would like to address one of the questions I got on one of my shear moment diagram videos. And the question says, I don't get it. You show the first moment as positive, yet you started to draw it below the line. I thought it should concave up initially since it's positive. Let me tell you what this means. I would like to make sure this person understands what I mean by drawing the moment below the line as positive. I'll take the example of a simply supported beam with a uniformly distributed load. So we have pin connection, and this is the uniformly distributed load on the beam. So this is the reaction. Let's say this is reaction A, and this is B, assuming this is point A and this is B. And as you very well know already, the shear diagram, this is the positive side and this is the negative. And the shear diagram looks like this. We started this point going up with the VA value, and then it's going to intersect right in the middle. And then we're going to go up with the VB value. And this is the positive side, and this is negative below the line. There you go. And now going to the moment diagram. This is going to be moment diagram. And if we were to keep this sign position, if I was to keep plus on the top and minus at the bottom, which you probably, or this person probably is used to do, this moment diagram would concave up, exactly like he says, right? And this would be the positive side. And this is how the diagram would look like. But this is not how I do it. This is not how we were taught in college. And it's not to say, it's not right or wrong. It's just that the way I do it, and I'll tell you the reason why we were taught to do it this way. So we were actually shown that as long as you show the signs here on the left, I'm going to put minus at the top and positive at the bottom. And as long as we show that, we can draw our diagram this way, right? There's nothing wrong in doing it this way as long as we show the signs. So now this is also the positive side. Even though it concaves down, the diagram is the same as I just drew it, right? With the positive up and the negative at the bottom. It's the same thing. And the reason we were told we can do it this way is that sort of this diagram resembles the deformation of the beam diagram. Because if the load pushes down, you sort of feel as if the beam is supposed to deformate this way. So this is how I am used to doing it. And if you are used to doing it the other way, please keep on doing the diagram the way you are used to. But just remember that the way I'm doing it, it's not incorrect. It's just it's the same thing as long as I show the signs here on the left side. Another thing I want to point out is the calculation of the reaction. I'm going to draw here the sign convention that you very well know. So this is the positive. Going left to right, this is the positive side of the moment, clockwise, and right to left, this is the positive side of the moment, counterclockwise. So when calculating the reaction, I want you to forget about this. It really does not matter, this sign convention. When you do sum of moment, let's say in point A equals 0, you go ahead and pick your positive direction and negative direction. If we pick, let's say, this as positive, then obviously we take the VB as negative. So we can say, let's say this is the resultant. We can say resultant multiplied by half of length minus VB multiplied by the entire L. And as long as you get a positive result, that means that you have chosen the reaction direction correctly. And if you get a negative result, let's say you get plus 100. So if you get a positive result, that means that you have chosen the correct direction, and then your value here of the reaction is 100. But if you do this calculation and you get minus 100, what that means is that the assumption that you've made at the beginning about the direction of your reaction is incorrect. So all you do, you keep the 100 value for your reaction, and you just change the direction of your reaction. Obviously, in this case, the reaction is upward, right? Because we have the load pushing down, the reaction is going to be upward. But sometimes it's not as easy to know the direction of your reaction. And to give you an example, if you have this, let's say, beam, simply supported beam, and you have a support here, and then another one somewhere here, and then you have another load here, let's say, 100 kips, right? And then this is a certain value. Now, depending on this load and on this distance, it's hard to know sometimes if the reaction is going to be upward or downward, especially right in this case, at this position. So usually we assume it upward. And then when we do sum of moments in point A and then sum of moments in point B equals 0, we find the value of the reaction. And if we get a positive number, that means the assumption we've made is correct. And if we get a negative value, all we do is we keep the value as 100, let's say again, but we just change the direction of our reaction. That's all we do. That's all I wanted you to know for today. I hope this makes sense. If not, I'll probably get another actual example next time to explain. If you have any questions, please leave your comments in the comment section below. Otherwise, I'll see you next week.